The next program is Sierpinski's triangle. Sierpinski's triangle is a very famous fractal that's been seen by most of the math students. This fractal consists of one large triangle which contains an infinite amount of smaller triangles within. The infinite amount of triangles is easily understood if the fractals is zoomed into many levels. Each zoom will show yet more previously unseen triangles embedded in the visible ones. Sierpinski's levels. So this is at the level, first level, second level, third level, and then fourth level, like that it goes on. So here this given triangle is divided into first level, and it is divided. This is the first level division, and again it is further divided into two triangles. This is the second level, one, and this one, and this is third level. This is the first level. Again this is further divided. This is the second level. This one, this one, this one, this one, and this is the third level. Okay, and similarly here the first one, second, third, and fourth. Okay, now for n is equal to 1, so it is the first level of division, and for n is equal to 2, this is the first one, and this is the second level of division. And for the third level, so you can see the first one, second, third, you have this third level of division. Okay, now aim is to build Sierpinski's tetrahedron with the divisions. So here there is an example of tetrahedron. There is an example with of the first one is one division, and this is two divisions and more. So here this is the front one, left, right, and behind is the third one, fourth one. Left, right, front, behind. Left, right, front, and behind. Okay, now this is how it looks. And now understanding the implementation. Here we are building triangles. The triangle is built, and so everything ends up becoming a triangle. So when everything ends up becoming a triangle, so there must be a code to write the triangle. So this is the code for the writing a triangle. So that is ABC, and a polygon, begin polygon, vertex A, B, C, and end. So this is, and division. Now next one is that we divide the points, point A, point B, point C, and M. And now how we are dividing it? So that is the dividing the triangle. So next triangle is formed by dividing a given edge. So a new triangle is formed dividing an edge, and this is, we saw what is the triangle there, and this is drawing it in the form of tetrahedron. A tetrahedron has 4 triangles, left, right, below, and backside. Okay, so this is the tetrahedron we have seen, and displaying the tetrahedron, and this is reshape function. This is orthogonal, projection mode, matrix mode, projection, load identity, orthogonal, left, right, left minimum, right minimum, y minimum, y maximum, z minimum, z near, z far. Okay, and this is the initialization of graphical utility toolkit. So now understanding that, let's consider m is equal to 1. That means we are trying to divide that tetrahedron, okay, into a part. The first one we'll try to understand in the form of a triangle. Okay, if it is a triangle, so if m is equal to 0, that here, then it will directly go here and it build a triangle. So that's it. When it point the, okay, let us look here. Divide function has a, b, c are the 3 points and m value. A, B, C are the vertices and M is the number of times it is to be called. So if M is equal to 0, then the direct ABC, the direct triangle is called. So you are building a triangle ABC, a triangle is formed. So now after this step, that if M is equal to 1, let's consider. If M is equal to 1, it is greater than 0, then a given 2 points finds the middle point, that is A, B and divide by 2, that is the midpoint of it. Again these two and again the midpoint of it. Again this the midpoint of it. So each midpoint is calculated, and if M is equal to 1, and it will further divide again. So if M is more than 1 and further divide, that means it goes for recursion if M is greater than 1. It goes for recursion. Equal to 1 or greater than 1, it goes for recursion. So when the recursion was, so this is you know the recursion, how it works. So it recursively divides and starts building step by step from the lower triangle. Okay, now it calculates the midpoint to form the new triangle and recursively called to divide the function. Okay, so now given triangle, so M is equal to 1. So this is how the triangle is built. Now how is it divided? How we are constructing it? Let us see. This is how, if M is equal to 1 and you get the tetrahedron, this is not a tetrahedron, the triangle with Sierpinski's triangle. So here the first one is A value is taken, B value is taken, this is A and B. So now A and B is divided V1. So that is what, A and B is divided to get V1. And next one is C is taken, and A and C is divided, A and C is divided to get V2 here. So then B and C is divided to get V3. B and C is divided to get V3. Now how do we call this? This is the recursion. Okay, so M is equal to 1 minus 1 0, that means there is no again recursion of it, so it will be called only once. So that means it will call here again. So first it is passed and again it is passed. So when it is greater than 0, it will fail this condition. It will come here, display A, B, C. That means it will display this A, V1, V2. A, V1, V2. So this is the first triangle it displays. And now the second one, it will go to the again it will go for the here the second one, that is C, V2 and V3. Again it will not come here because M is 0 here, so it will directly build the triangle. Again it will go to the B, V1 and V3. V3 and V1. So it will display this one. So this is for the triangle. Okay, so that means one side. In the tetrahedron there are totally 4 sides. This is for one side. So when n is equal to 0, this is a triangle, and when is equal to tetrahedron, it becomes the 1, 2, 3 and below is the fourth one. So there are 4 sides in a tetrahedron. We can see this. That's the last one. Yellow is the below one. Okay. So now this is the color is red. So this part, that is V0, V2, V1 and V2. Again the function divide function is called for this one. So it will do the same thing what we saw in the previous slide. So it will divide this according to the number of M. So then it will call the number of times, it will call the recursion and it will complete it. Again for this, the below one, this is yellow, and this is blue, this is V0, V1 and V3 and V1. So for this, and the last one is tetrahedron. Okay, now the next part is, so this is the tetrahedron and the triangle is displayed. The triangle, it calls the triangle. Okay, so and it will be displayed. Now tetrahedron with 1 division and 2 divisions, for example. Okay, so you hear the tetrahedron with 1 division. Okay, so this is tetrahedron with 1 division. This is tetrahedron with 2 division, left, right, front and behind. Okay, so let's look at if n is equal to 3. So this is the left part, this is the right part. Okay, so this is the back part, and this is the front part. So, and you can see here, so left, right, front and behind. Okay, thank you very much.